Thank you very much, and good afternoon. It's wonderful being here. I hope everybody can see at least one of the two slides. I have very limited time, but I'm going to walk you through some key points in two projects that I've carried out. One I've completed and one I'm completing now for the Canadian Environmental Assessment Agency. First, I'm going to talk just very briefly, everything's going to be brief, about how climate change impacts on the design of infrastructure projects. Now, this isn't to say that I'm dealing at the project level EA, not at strategic level, and that's clearly also important. I'm going to talk a little bit, very briefly, about how to assess the impacts under different types of scenarios, and then what do we do with the information in order to make a decision about adaptation to climate change where we don't understand or at least know what the climate's going to be like. So just some very brief examples. Climate's going to affect stream flows. Stream flows will affect hydroelectric power projects. Water levels will affect marinas. Rainfall will affect the design of stormwater collection systems, and changing winds from climate change will affect structures, and therefore the design of all of these. And as was mentioned by somebody this morning from Canada, permafrost is certainly an issue, and we build pipelines over permafrost and roads over permafrost. Well, as those may melt or will melt in varying degrees in certain locations, then how do we plan for climate change given all of the uncertainties? The example that I'm going to be using, and I've used in both of my research projects, are about climate change affecting stream flows, which affect energy production, as well as the impacts of the project on people and the environment, for example, flooding. Here's a model of, well, you can walk through it. On the left is a climate model. Well, historically or traditionally, we would design the hydroelectric project, which is the red dot there, in terms of a stream flow model based on historic stream flows, but now we have climate models. So we'll have climate is changing, which will affect stream flows through our stream flow models, and then those affect energy and greenhouse gas reductions because of a hydroelectric project, and also affect fisheries and floods and so on. So I want to look at how we do that. We can do it through a number of different methods. Certainly in climate change, scenario analysis is an important tool, perhaps the most important, where we have, and in the hydroelectric power projects, we would take our historical stream flow data, modify it according to various scenarios, and I've done this over a period for many different scenarios over a period of about 2010 to 2100. Here's an example with just a small set of scenarios. You can have dozens and dozens of these scenarios, and this is a fairly limited set, and this shows through time from 2010 to 2100 the historical, which is these are stream flows in the vertical axis, and this is the historical is in the black, which you probably can't see that easily there, and the other four scenarios are also shown there, and again, this could be done over dozens of them. This is a fairly narrow range of scenarios when this was done about 5 or 6 years ago when we did it. And then what we need to do, however, we don't know what scenario is going to occur. We need to design for climate change and choose, in this example, choose a capacity for the hydroelectric project, just one design variable based on future climate change. And this is if we design it. Here's one example where we've designed it based on a very high stream flow, sort of a measure of average high level of stream flow, so that we would see a relatively high energy production. So we've designed the project, in this case a hydroelectric project, to respond to a very high level of climate change. And this is the energy production we would get out of it under various scenarios, including the scenario for which we designed it. Now, what happens if we change the design to respond to moderate or low climate change? And we'll get that amount of output from the project. And you can do this for any impact. I mean, this happens to be a positive impact in terms of the purpose of the project, which is hydroelectric power. But you can project other types of impacts, negative ones included, which I'll get to in a minute. So the before, we would get that output with a certain design based on high climate change, significant climate change, and that with very modest climate change. So we don't know what's going to happen. So which one do we choose for? And this shows the results. Again, it's a very limited range of climate change, and we've designed on the left the scenario. This left is the energy output that we get with one scenario, and the right is when we've designed it for another scenario, but the results differ based on what scenario actually occurs. So we have to design it now, not knowing what the scenario is going to be in the future. So we have these numbers. We can get them for certain things, and it could be quantitative or qualitative, depending upon what the impact is and how much work we want to do in our analysis. So which scenario to design for? Well, somebody would say, well, if you want more high energy output, design for the overbuild it. Build it large to capture the potential for a lot of stream flow based on significant change in climate or significant change in increase in precipitation. But it costs more. And it may have other impacts too. For example, it may exacerbate flooding by that design. So we must make decisions in the face of high uncertainty about what future climate will actually look like, but we need to make that decision now, sort of, which I'll get to. So some approaches are you can use criteria for decision making under uncertainties. There are a number of criteria that have been developed for other purposes. An example of that, minimize the maximum impact. Maximum negative impact, that's a very risk-averse strategy. Another significant type of risk-averse strategy would be to minimize the maximum regret by, after the fact, seeing that you made the wrong decision. Or adaptive management, which is to build in flexibility to change in the future as you see climate change unfolding. But that would cost you more, typically, to build in that flexibility. So I'm going to give you a couple of examples. Similar to what I just showed you before with the hydroelectric project, just imagine this. This is now some numbers of whatever impact you want to imagine in your own field. These are adverse impacts, measures of adverse impacts, and we have design A and design B. And we have possible future scenarios 1, 2, and 3. And if I gave you those numbers, what would you choose? It's not clear. There's no design A and design B are better under different scenarios. If I thought scenario 1 was going to occur, then I would pick design A. If I thought scenario 2 was going to, design A. If I thought scenario 2 was going to occur, I'd choose design B. And if I thought scenario 3 was going to occur, I'd choose design A. But I don't know which scenario is going to occur. What do I do? Well, one example of using a criterion, a very simple one, is if I'm risk averse, what's the worst that will happen? Well, if I choose design A, 70 will occur, 70 bad impacts, levels of bad impact. If I choose design B, it'll be 80. Well, I want to protect myself, so I'll choose design A because the worst that's going to happen is going to be 70 instead of 80. Very simple. But first it requires us to acknowledge uncertainties, to assess the impacts under various scenarios, and then to look at the numbers, and then to apply some sort of criterion that we agree on, or different people might have different criteria. Here's the other one, which is about minimize the maximum regret, and I'm not going to go through it in detail, but if scenario 1 was to occur, let me show you this. We would pick design A and we'd be happy, no regret. If we pick design B and scenario 1 occurs, then I'd say, oh, shoot, I should have picked design A. I regret it by 20, so there's my 0 and 20 shown on here for scenario 1. And then I'd say, well, I don't like to be mad at myself, so if I look at design A, then the maximum regret I'm going to have is 50. If I choose design B, the maximum regret is 30. Well, I would prefer to choose the one where I kick myself in the pants less, so that's going to be design B. So one criterion leads me to design A, another criterion to design B. But the point is, we are acknowledging the uncertainty, we're looking at it, and we're having a discussion about what the effects will be, and thinking about and talking to our stakeholders about how do you view risk. Adaptive management is a very different approach where we don't have to make the decision up front. What we do is, let me walk you through this a little bit. Time is on the x-axis. We're going through time, and we see the impact, the negative impact or the adverse impact in the vertical axis, and we see that it's climbing through time as climate unfolds. Well, what I can do is when I'm building, instead of design A or design B, or when I'm designing, I can build in flexibility. And in the vertical axis going down is, in a sense, cost. So I can build design A, but pay for some flexibility. It could be a levee with some additional supports underneath that I could increase the levee higher, or the hydroelectric dam, build in something so that I can respond to climate change later, or the pipeline with permafrost melting. So I pay additional cost for design A with flexibility. And then as time moves on, if I see climate change unfolding in a certain way, I could decide to adapt to the climate change and you see over there on the dashed line going down, use flexibility to change to design B if a certain scenario occurs. Well, if you remember, that I would rather have design B if I see scenario 2 occurring. So if I see scenario 2 occurs, change to design B. If I see scenario 1 staying, keep it design A. And I've wasted that cost of flexibility, but I've allowed myself the flexibility in case it's scenario 2. So and then you see, if I design B, then it goes flat, the impacts don't get any worse. And here's how I can show it with that matrix from before. I had design A and design B. Well, now it's design F. I've added on a flexibility design, an adaptive management design. And under scenario 1, I stay with 40, I don't change to design B. Design F stays as design A. If I see scenario 2 occurring, then I change to design B and I get only the 20 instead of the 70. And if I see scenario 3, I stay with design A also and I get 50. So it really gives me the best of everything, but it's cost me money and I have to factor that in. So the conclusions are, we need to identify how climate change might affect the project, consider the range of alternatives to respond to them, predict the impacts of those, as I've shown in that type of matrix. It's a very simple example. Consider the attitudes toward uncertainties, how risk-averse I am, and talk to people about it, and that requires some transparency. And we've also suggested some guidelines I think guidelines are needed to assist proponents in terms of addressing these types of issues. Thank you.